I'm not being very responsible.
It's just one of those days, Miss Ford.
It's just one of those days. All right, we are on the back of page 63. We did 63 last time. And I'm going to make a little list over here of the formulas that we have used so far. We have used these two formulas. Yep, good. We're going to be getting some more today. Remember, you never have to memorize these, okay? So for the quiz, for the quest, for the exam, all of those, I'm going to give you the formulas, so you do not have to memorize them. You do have to know which one goes with which. So we remember that the D stands for common difference, so that's for arithmetic sequences. The R stands for common ratio, and that is for geometric sequences. Now, we're diverting for a moment because we're going to do a little calculus today. We're going to talk about the limits of these sequences, okay? We're going to find the limits of these sequences. Now, when I say there's a limit, what I mean is, as the sequence marches on, it heads toward a wall that it can't cross over. An example of that would be number 2, or B, letter B. Okay, we are on part 6 in our notes, back at page 63, and I'm looking at B. Tell me what's happening to these terms. Now, first of all, you should see the pattern. What am I doing here? Multiplying by 1/3. So the next would be 1 over 81 and 1 over 243. Tell me, what are those terms doing? They're decreasing. The terms are getting smaller, right? The numerators get, or denominators getting bigger, but the terms are getting smaller. If I keep going, will they ever be negative? No. They're just going to get smaller and smaller and smaller. So think about it on a number line. Here they come. They're getting smaller and smaller and smaller and smaller. But what are they never going to go past? What is the wall? 0. Because if they went past 0, they'd be negative, right? And you're telling me these are never going to be negative, and you're right. So the limit of that sequence is 0. The limit, what we call the limit, is 0. It's the wall that we can't cross. Now, look at A. What's going on with A? Those terms are getting bigger and bigger and bigger. Is there a wall? They're going this way. Is there a wall that they won't go past? No. So A has no limit. A has no limit. Those terms are just getting bigger and bigger and bigger. What about C? Think about that for a second. What? We're multiplying by -2. That's right, it's geometric. So the next term would be positive 64, and then negative 128, and then positive 256. Are those guys approaching anything? Is there a wall that's going to stop them? No, they're flipping back and forth, positive, negative, but they keep getting bigger and bigger, so that one has no limit. Now, the rest of these are not even written out as a sequence. They're written kind of as a formula. So I want you to, I put a bracket from D to H. These are all the same kind of problem, and I'm going to give you some rules for problems like D through H. We've actually done those before. Back in the day when we were graphing and you had to find a horizontal asymptote, you found limits. That's what you did when you found your horizontal asymptote. Does anybody remember what the limit for n, this is the way the notation would be, what the limit for n over n plus 1 would be? Anybody remember how we did that? We looked at the highest power. Does that sound familiar? Oh, I did a terrible job. We did this. We really did this. When we graphed these, we have n over n. So the limit is 1. N over n. The next one, E, we have the limit of 2n minus 8 over 3n plus 6. So what's that one? 2/3. Starting to look familiar now? What's F? 4/5. We look at the highest power. So what's the highest power in F? N squared? So we've got 4n squared over 5n squared? 4/5. Now, G is where they start getting tricky. Anybody remember how to deal with that? We did. We talked about these. You remember? That's an idea, but not when we're evaluating a limit. What is the highest power in the whole problem? N squared. So on the bottom, I have 5n squareds. How many do I have on the top? How many n squareds on the top? 0. So there's your fraction, kids. What's 0 over 5? 0. So the limit of that one is 0. If your powers match, then it's easy. If they don't match, then you got to put a 0 in where it's missing. So let's look at H. What do we have? What's the highest power in H? So I got 8 on top. How many n squareds on the bottom? 0. What's that? No solution, no limit. Now I'm going to give you the math word for that, but you don't have to use it if you don't want to. But when something does not have a limit, it is called divergent. Divergent means shoots off into space. Okay, we good? Everything good here? All right, so that's how we do those problems. So when we have the n's over the n's, when we have n's over n's, we compare them. If they match, good, that's it. That's the answer. If they don't match, you're going to have to put a 0 in somewhere. If the 0 is on top, then the answer is 0. If the 0 is on the bottom, then the answer is no answer. Okay? Now, the rest of the problems, I through L, are also the same to each other, but they're different. They're a different kind of problem. Oh, I probably should erase that very well. When we find the limit, there's 2 different situations that can happen. One is this, and one is the next one. So this is I and J. Can anybody tell me what happens if, excuse me, what happens if we multiply by 2/3 times 2/3 times 2/3 times 2/3 and keep going times 2/3? Does your result get bigger and bigger, or does it get smaller and smaller? Smaller and smaller. So if you are multiplying by more and more 2/3, that limit is going to eventually be 0. Now what happens though if you multiply by 5/4? Getting bigger. If you multiply something by 1.25, it gets bigger, right? So this one is divergent. These kind of problems, kids, are real simple. The answer is always either 0 or divergent. And the key is this number right here. What can you tell me about that number right there? If it's bigger than 1, divergent. If it's less than 1, 0. Every time. You don't worry about anything else in the problem. There might be a number out here, don't worry about it. There's an exponent, don't worry about it. The only thing you worry about is the number in the parentheses, Jake.
Hurry up.
Alright, so look at K. What do you think the answer to K is? Divergent. Because 1.5 is more than 1. What do you think about L? 0. Because 0.8 is less than 1. Alright, that's your limit practice. Okay? The exponent will never affect the limit unless the exponent is negative. So if we put a negative 4n on there, that would turn the fraction upside down. Okay? So that's the only time you have to worry about it. I'm not going to trick you guys that way, but that would impact it. Turn it upside down. Okay, Robbie.
Yeah.
Look alive. All right, here we go. 9.5. This is the last thing we're going to do. 9.5, 1, 2, and 3. We're not doing 4. So 1, 2, and 3. Here we go. Find the sum of the following series. Now, I want to wait. I want to back up a minute. And I want to look at this sequence of numbers right here. Can somebody tell me what kind of a sequence that is? Arithmetic. It's arithmetic, and its difference is what? What are we doing? Adding 5. So a little bit of review. You don't have to write this down. Pay attention. This is review. If I said, okay, I got a bunch of terms here. Suppose I wanted the 100th term. I have a formula that will do that for me, right?
That'd be the multiplication.
That is the formula that will find the 100th term. So let's practice with that. The 100th term, a sub 100 equals what? Negative 18 plus 5 times. Okay, but what's n? So it'd be 99. Yep, good. Now that's not the question on the quiz or on the paper, guys, but this is review. This is what we talked about the other day. 477. You can find any term you want. If somebody said, let's find the 2000th term, could we do that? Yeah. You can find any term you want using that formula. Now, that is not what question A says. Question A says, find the sum. Now that means take all of these numbers and add them up. Could you do that? You're sitting there with a calculator, you could just type all those in, right?
Yeah.
But what if there were 100 of them there?
It'll take a while.
It'd take a long time. So we have a formula that will find the sum. And again, you have to know how to use it. You do not have to have it memorized. See the S? The S in the formula? That's your clue for sum. Alright? So if you're told to add these up, if we're told to add those up, then we're going to use that formula right there. Now, how many terms are you adding up? 1, 2, 3, 4, 5, 6, 7, 8. So it's S sub 8. N stands for what it always stands for, the number of terms. So I have 8 terms. Alright, now here's your new formula, very new formula. There's that N again. These are the same N, guys. There's 3 of them. They're all the same. So it's 8 over 2. What does this mean? First term, which is negative 18. Now remember, N is 8. So this says A sub 8.
Why is that 8? Just because.
N is the number of terms, and we counted them. Right? We counted them. We said there were 8. What does A sub 8 stand for? What do we mean when we say A sub 8? We mean the number in the 8th spot. think those all add up to -4. Now, in case you don't believe me, let's take our calculators out. Let's just add them up.
So then, when you get -4, then
That's the answer. That's the sum.
Oh.
Your job was to sum all those up, and we got -4. Marley?
So all the ends don't equal 8, it's just the first two?
No, all the ends equal 8.
So how'd you get 17?
Okay, A sub 8 means the 8th term. A sub 8 means the 8th term. Just like A sub 1 means the first term. So the number that's in the 8th spot, Marley, is 17. All right? Here we go. This is letter B, asking us to do the same thing. We're going to add these up, but this is a little bit different. What's different about this set of numbers? It's geometric. Okay, this formula, these are your arithmetic formulas. Do not use them for anything that's not arithmetic. If it's geometric, the formulas we're going to use are these. That one you've already used before. There we go. Though that's your formula for a sum that's geometric. All right, so here we go. What's in? How many are we adding?
5.
1, 2, 3, 4, 5. So we want to add up 5 of them. So the sum of 5 terms, okay, is going to equal what? Use your formula.
2.
So what's the first term? -2 minus -2 times, what's your ratio?
you get 5.
3.
Plus.
What's your
Minus.
ratio?
Oh, okay.
3 to the 5th over 1 minus 3. Your first term is -2. There are 5 terms, so n is 5. The ratio is 3. I just plug all those numbers in. Now, what happens when you minus a negative? So we have -2 plus 2 times 3 to the 5th over -2 if I just subtract 1 minus 3. So on your calculator, just type -2 plus 2 times 3 raised to the 5th. And remember, when we raise, we use that button right there. That's raised to the 5th. It equals, and divided by -2. You should have gotten -242. Okay? So anytime the directions say add, sum, we're going to use either this formula or this one because they have the S's. That stands for sum. How do you know which one to use? Well, you have to know what kind of sequence you have. If you're adding different term to term, you're going to use this one. If you're multiplying, you're going to use this one. All right, there's one more in this little section. says find the sum, and we are adding up these. Alright, this one is going to challenge us a little bit. So let's see if we can get it done before we run out of time. This one's going to be challenging. First of all, what's going on? How am I getting from term to term here? Can you tell?
Wait, are we skipping C?
Oh, I skipped C. Sorry. Well, let's do D and we'll come back and get C. I skipped it. Sorry. Anybody see it? Divide by 2? Well, if we divide by 2, that would be 0.04. And it's 0.4. These numbers are getting bigger.
Multiply by 5.
Oh, multiply by 5. Try that on your calculators. Take this times 5. Take this times 5. I think she's right. We're multiplying by 5. Gotta figure it out, Deshani. We're smart kids. Alright, so I'm adding them up. We're timesing by 5. Which formula am I going to use? This top or bottom? Geometric. So oh no! What do I not know? I know the first term. That I don't have a problem with.
How many?
I don't know how many there are. Oh shoot.
N plus whatever.
So,
I gotta figure out how many there are. Now you have a couple of choices. One is, you already know how you're making these terms, right? You are timesing by 5. So what would be the next term here? 10. And then what? 50. And then 250, you're timesing by 5, and then that one.
1, 2, 3, 4,
So 1, 2, 3, 4, 5, 6, 7. So we're adding up 7 of them. That wasn't so bad. Then you would have to use this formula right here to figure out what n is. And I don't have time right now to do that, but you could do that. Alright, so 7, sum of 7. Here we go. We're adding first term 0.08 minus 0.08 times, what did you say the ratio was? 5 to the 7 over 1 minus the ratio. So I'm going to type it on my calculator. 0.08 minus 0.08 times 5 raised to the 7 equals divided by -4. And did you get 1562.48? That's your answer. All right, so we still have a few more notes to finish. Then I want to do the quiz review I gave you before we take the quiz. So our quiz will either be at the end of the period tomorrow or Thursday. Okay? All right. Remember, some of you will be taking the quest. Thank you, Joseph. Thank you, Chris. And
This has been brought to you by Miss Ford's C period.
Scully gang.